Good day, students! In the previous video, you've learned about introduction of logarithmic function, its parts and terminologies, solving logarithmic using calculator, difference between logarithmic function, equation, and inequality, and converting exponential equation to logarithmic equation. Then, solving logarithmic equation. Now, let's proceed to logarithmic equation, property of equality. Here, we let b be a positive real number and b should not be equal to 1. Then we'll have logarithm of m with base b is equal to logarithm of n with base b, if and only if m is equal to n. So let's try it to some examples. Example number 1, with given logarithmic of x with base 3 is equal to logarithm of quantity 3x minus 4 with base 3. Using property of equality for logarithmic equation, we'll have x is equal to 3x minus 4. Then use addition property of equality to 3x, we'll have x minus 3x is equal to 3x minus 3x minus 4. Simplify, we'll have negative 2x is equal to negative 4. Then use multiplication property of equality to negative 2x. We'll have negative 1/2 multiplied by negative 2x is equal to negative 4 multiplied by 1/2. Again, simplify, the answer will be x is equal to 2. So using the value we got, we're going to check if it satisfies the given logarithm by substituting it. Again, with given logarithm of x with base 3 is equal to logarithm of the quantity 3x minus 4 with base 3. Substitute 2 to all x's, we'll have logarithm of 2 with base 3 is equal to logarithm of the quantity 3 multiplied by 2 minus 4 with base 3. So the answer would be logarithm of 2 with base 3 is equal to logarithm of 2 with base 3. Since it satisfies the given logarithm, therefore, we can say that the solution set is 2. Next example, with given logarithm of quantity 3x minus 2 with base 2 is equal to logarithm of quantity 2x minus 6 with base 2. So using again the property of equality for logarithmic equation, we'll have 3x minus 2 is equal to 2x minus 6. So using addition property of equality to 2x, we'll have 3x minus 2x minus 2 is equal to 2x minus 2x minus 6. Simplify, so we'll have x minus 2 is equal to negative 6. Again, using addition property of equality to negative 2, we'll have x minus 2 plus 2 is equal to negative 6 plus 2. Simplify, we'll have x is equal to negative 4. So again, we're going to check if x is equal to negative 4 satisfies the given logarithm. So we'll have logarithm of quantity 3x minus 2 with base 2 is equal to logarithm of quantity 2x minus 6 with base 2. Substitute negative 4 to all x's, we'll have logarithm of quantity 3 multiplied by negative 4 minus 2 with base 2 is equal to logarithm of quantity 2 multiplied by negative 4 minus 6 with base 2. Then simplify, we'll have logarithm of negative 14 with base 2 is equal to logarithm of negative 14 with base 2. As you can see, we come up to having an equal logarithm, but since we cannot have a negative logarithm, for this will give us an imaginary results. Therefore, we can say that x is equal to negative 4 is rejected since it is not in the domain of the given equation. Hence, there is no solution. So let us now proceed to the laws of logarithms. Here in the first law of logarithm, there are 3 things you need to familiarize. First one, the logarithm of b with base b is equal to 1. Second one is the logarithm of 1 with base b is equal to 0. Then the last one is the logarithm of b raised to x with base b is equal to x. where b is greater than 0 and b should not be equal to 1. The first one can also be called as logarithm of the base. The second one can also be called as logarithm of 1. Then the third one can also be called as logarithm of a number. So let's try some examples. So the first one, with given logarithm of b with base b is equal to 1, so using the equivalent exponential form, we'll have b raised to 1 is equal to b, or we just simply change it to its exponential form. So as you can notice, any number raised to 1 will always be equal to its base. So simplifying this using the law of exponent of 1 or logarithm of the base, we'll have b is equal to b. Next one, with given logarithm of 1 with base b is equal to 0. So using the equivalent exponential form, we'll have b raised to 0 is equal to 1, or simply change it to its exponential form. So here, as you can see, any number raised to 0 will always be equal to 1. So simplifying this using the law of zero exponent or logarithm of 1, we'll have 1 is equal to 1. Then the last one, with given logarithm of b raised to x with base b is equal to x. So using again the equivalent exponential form, we'll have b raised to x is equal to b raised to x. So this implies that any number having a base that is greater than 0 and not equal to 1 will always give you its equivalent number. So to further understand this, let's try it with given values. So example number 1, under logarithm of the base, with given logarithm of 6 with base 6 is equal to 1. So using the equivalent exponential form, we'll have 6 raised to 1 is equal to 6. So again, using the law of exponent of 1 or logarithm of the base, we'll have 6 is equal to 6. The logarithm of 1 with given logarithm of 1 with base 2 is equal to 0. So using the equivalent exponential form, we'll have 2 raised to 0 is equal to 1. Then using the law of zero exponent or logarithm of 1, we'll have 1 is equal to 1. Next is the logarithm of a number with given logarithm of 7 raised to 1 with base 7 is equal to 1. Using equivalent exponential form, we're going to have 7 raised to 1 is equal to 7 raised to 1. So that would be the answer for the logarithm of a number. But if you are required to get the simplest form, so we're going to use the law of exponent of 1 or logarithm of the base. So we'll have 7 is equal to 7. Let's proceed to the second law of logarithm, the logarithm of products. This law states that the logarithm of the product of positive real numbers is equal to the sum of the logarithms of the factors of the given base. In mathematical symbols, logarithm of the product mn with base b is equal to the sum of logarithm m with base b and logarithm n with base b. Let's try it with given values. So example number 1, with given logarithm of the product 3 and 5 with base 2. So using the logarithm of products to expand the given, we'll have logarithm of the product 3 and 5 with base 2 is equal to the sum of logarithm of 3 with base 2 and logarithm of 5 with base 2. Next example, with given logarithm of the product 2xy with base 3. So using the logarithm of the product or the second law of logarithm to expand the given, we'll have logarithm of the product 2xy with base 3 is equal to the sum of logarithm of 2 with base 3, logarithm of x with base 3 and logarithm of y with base 3. So last example, we given logarithm of the product 5x and 7y with base 4. So we're going to use the second law of logarithm or the logarithm of products and have logarithm of the product 5x and 7y with base 4 is equal to the sum of logarithm of 5x with base 4 and logarithm of 7y with base 4. So as you can see, we can still expand 5x and 7y by using again the logarithm of products or the second law of logarithm and have logarithm of the product 5x and 7y with base 4 is equal to the sum of quantity logarithm of 5 with base 4 plus the logarithm of x with base 4 and the quantity logarithm of 7 with base 4 plus logarithm of y with base 4. I use the parenthesis symbol to represent a group for us to easily compress the given whenever we are asked to. With base b, let's proceed to the third law of logarithm, which is the logarithm of quotient. This law states that the logarithm of the quotient of two positive real numbers is equal to the logarithms of the dividend minus the logarithm of the divisor. In mathematical symbols, we have logarithm of the quotient m over n with base b is equal to the difference of logarithm of m with base b and logarithm of n with base b. Let's try this example with given logarithm of the quotient 3 over 5 with base 2. So using the third law of logarithm or logarithm of quotient, we'll have logarithm of the quotient 3 over 5 with base 2 is equal to the difference of logarithm of 3 with base 2 and logarithm of 5 with base 2. Next example, with given logarithm of the quotient 4a over b with base 3. So we're going to use the third law of logarithm or the logarithm of quotient. We'll have logarithm of the quotient 4a over b with base 3 is equal to the difference of logarithm of 4a with base 3 and logarithm of b with base 3. So as you can notice, we can still expand 4a using the logarithm of product or the second law of logarithm. So we'll have logarithm of the quotient 4a over b with base 3 is equal to the difference of the quantity logarithm of 4 with base 3 plus logarithm of a with base 3 and logarithm of b with base 3. As you can see, I put the expanded form of 4a inside the parenthesis for us to know that this, when we are asked to get its original form, we know that it is equal to this. Let's proceed to the fourth law of logarithm, which is the logarithm of power. Here, it states that the logarithm of the power of positive real numbers is equal to the exponent multiplied to the logarithms of the factors of the given base. In mathematical symbol, we'll have logarithm of m raised to the power of a with base b is equal to the power of a times the logarithm of m with base b. Let's try this example with given logarithm of 3 raised to 5th power with base 2. So using the fourth law of logarithm or the logarithm of power, we'll have logarithm of 3 raised to 5th power with base 2 is equal to the power of 5 times the logarithm of 3 with base 2. Next example. So if you're going to observe the given, this is an example of logarithm of product with application of logarithm of power. So we'll write it as logarithm of the product quantity x plus 5 raised to 1/2 and 3x with base 2. So using the logarithm of product or the second law of logarithm, we'll have logarithm of the product quantity x plus 5 raised to 1/2 and 3x with base 2 is equal to the sum of the logarithm of quantity x plus 5 raised to 1/2 with base 2 and logarithm of quantity 3x with base 2. As you can see, we can still expand the quantity x plus 5 raised to 1/2 by using the logarithm of power and also the quantity 3x by using logarithm of products. So we'll have logarithm of the product quantity x plus 5 raised to 1/2 and 3x with base 2 is equal to the sum of the power of 1/2 times the logarithm of the quantity x plus 5 with base 2 and logarithm of 3 with base 2 plus the logarithm of x with base 2. Last example. So obviously, this example is under the logarithm of quotient with application of logarithm of power. So we'll write it as logarithm of quotient square root of a plus 7 over cube root of a plus 11 with base b. So using the logarithm of quotient, we'll have logarithm of quotient square root of a plus 7 over cube root of a plus 11 with base b is equal to the difference of logarithm of square root of a plus 7 with base b and logarithm of cube root of a plus 11 with base b. Next is simplify the square root of a plus 7 and cube root of a plus 11 by using the law of fractional exponent to change the radical symbol to its fractional form. So we'll have logarithm of quotient square root of a plus 7 over cube root of a plus 11 with base b is equal to the difference of logarithm of quantity a plus 7 raised to 1/2 with base b and logarithm of quantity a plus 11 raised to 1/3 with base b. So using the logarithm of power to logarithm of quantity a plus 7 raised to 1/2 with base b and logarithm of the quantity a plus 11 raised to 1/3 with base b, we'll have logarithm of the quotient square root of a plus 7 over cube root of a plus 11 with base b is equal to the difference of the power of 1/2 times the logarithm of quantity a plus 7 with base b and the power of 1/3 times the logarithm of quantity a plus 11 with base b. That's all about the laws of logarithm. But before we end this video, let's try this example with given values. Given that logarithm of 3 with base 5 is equal to 0.6826 and logarithm of 2 with base 5 is equal to 0.4307, we are asked to find the logarithm of 4 with base 5. So the first thing we need to do is get the factor of 4. So we'll have logarithm of 4 with base 5 is equal to logarithm of 2 to the second power with base 5. Then use the logarithm of power, we'll have logarithm of 4 with base 2 is equal to the power of 2 times the logarithm of 2 with base 5. Now, substitute the value of logarithm of 2 with base 5. So we'll have logarithm of 4 with base 5 is equal to 2 multiplied by 0.4307. We'll have logarithm of 4 with base 5 is approximately equal to 0.8614. So you may check it and use your calculator if it is really the approximated answer to the given. So the next exercise, with given logarithm of 3 with base 5 is equal to 0.6826 and logarithm of 2 with base 5 is equal to 0.4307, you are asked to find the logarithm of 24 with base 5. So I will be giving you 15 seconds to answer this, and we're going to check if we have arrived at the same answer. So let's check. So if you have arrived at this answer, which is logarithm of 24 with base 5 is approximately equal to 1.9747, then your answer is right. Thank you for watching.